Friends, welcome to AKB and this is Vishnu. So this illustration is regarding optimum product mix. So going forward with the illustration, we limited produce two products P and Q. The draft budgeted for the month also given. The budgeted production and sales are 40,000 and 60,000. Then selling price is given as 25 and 50. Total cost per unit 20, 40. Machine hour per unit is 2 and 1. Maximum sales potential per month is 60,000 and 1 lakh unit. After that, they have given some of the other details. The fixed expenses are estimated to be 9,60,000 per month. The company absorbs fixed overhead on the basis of machine hour. So the company absorbs fixed overhead on the basis of machine hour, which are fully utilized by the budgeted production and cannot be increased. Going further, when the budget was discussed, the management director states that the product mix should be altered to yield the optimum product. So the optimum product mix shall be computed by us. The marketing director suggests that he could introduce a new product C, each unit of which takes 1.5 machine hours. However, a processing what involves a capital outlay of 2 lakh, which is to be installed for the processing product. The additional fixed overhead related to the processing of what was estimated as 60,000 per month. The variable overhead our product C was estimated as 21 per unit. Then the requirement number 1, calculate the profit as per draft budget for the month. Second one, revise the product mix based on the data given by P and Q to yield optimum product mix. Number 3, the company decides to discontinue either product P and Q, whichever is giving lower profit, and proposes to substitute product C instead. Fix the selling price of product C in such a way that to yield 50% on return on additional capital employed, maintaining the same overall profit as envisaged in section 2, requirement 2 above. So guys, going directly towards the solution, here they have given total cost per unit. In the other problems, they have been giving the variable cost and fixed cost separately, but in this illustration they have given the total cost per unit. So at first we need to split this total cost into variable cost and fixed cost. Before that, we need to compute the total profitability statement as per requirement 1. So therefore we are making a table which containing 4 columns, particulars P, Q and one total column. Then we are taking budgeted production as 40,000 and 80,000. Going further, selling price 25, 50. Total cost is 20 and 40 respectively. Then we have a profit per unit as 5 and 10, and when we multiply this profit with the total production, we will get the total profit as 2 lakh and 8 lakh. So the total profit for the month will be 10 lakh. After that, we can segregate the we should segregate the fixed cost and variable cost. For that, we take the total cost of the product as 8 lakh and 32 lakh. That is cost of the product cost per unit of the product multiplied by total production unit. Therefore, the total cost is 40 lakh. Then so total hours per unit, that is for product P it is 2 per unit and product 1 it is 80. So the total budgeted quantity will be 40,000 multiplied by 2 and 80,000 multiplied by 1, then 80,000 and 80,000 each machine hours. When we take the total, we'll get 1,60,000 machine hours. So therefore, as you all know that when we compare these production hours, we can analyze the proportion as 2:1. That is, the machine hour for product P is 2 and the machine hour for the product Q is 1. Therefore, for substituting the fixed cost, that is 9,60,000 is the fixed cost divided by 1,60,000, which is the total hour multiplied by 2, and the same way 9,60,000 divided by 1,60,000 into 1, which will give you 12 and 6 respectively. So we have computed the fixed cost as 12 and 6, and then we have the variable cost, total cost as 20 and 40, and when we deduct the fixed cost from the total cost, you will get the variable cost as 8 and 34. Then after deducting the variable cost from the sale price, we get the contribution as 12 and 6. Machine hour, as we have discussed, it is 2 and 1. When we divide the contribution with the machine hour, we will get machine hour contribution per machine hour unit, that is 8.5 and 60. So from here we can rank this product. The product which gives more contribution per machine hour is ranked as 1. Over here Q has more contribution per machine hour, which is 16 than P. So therefore we need to give the first rank to product Q and then second rank to product P. Going towards the next part of the illustration or net part of the solution, statement showing computation of optimum product mix production. So total production is, as budgeted production is 40,000 and 80,000 unit. When we multiplied it with machine hour, we get total hour, which is 80,000 and 80,000, which is 1,60,000. So we have 1,60,000 hours. So these hours should be allocated in such a way to get the maximum profit from these products, the mix in which you will get the maximum profit. So the maximum sales potential is 60,000 and 1 lakh. So first we need to take the first rank item. So first rank item is product Q. So we need to allot 1 lakh hours, 1 lakh unit multiplied by the machine hour, which is 1. So 1 lakh into 1 will give you 1 lakh. 1 lakh hours. So 1 lakh hours should be allocated for machine Q, and then we need to take the rest hour, which is the total machine hour available is 1,60,000 minus 1 lakh, which is allocated in Q. So we'll get the remaining hour is 60,000, which can be allotted for machine Q P. So the machine hour per unit of P is 2 hours. Therefore 60,000 is the remaining hour divided by 2 will give you 30,000 unit. Therefore, the optimum product mix will be the product P is 30,000 and product Q is 1 lakh. And the contribution per unit is 17 and 60, and when we multiply it with optimum mix with the contribution per unit, we will get total contribution is 5 lakh 10,000 and 16 lakhs, total 21 lakh 10,000, and when we deduct the fixed cost, we will get the total profit as 11 lakh 50,000. Going further, at the third part of the question, they have asked us to substitute product C for the low return or the low profitability product, which is product P. So the product P shall be discontinued and product C shall be adopted. Therefore, the computation of selling price of product C should be variable cost is 21 per unit, and we have 60,000 hours, right? When we discontinue the product B from second optimum mix, we will get 60,000 as total hour. Then okay, then let's take that apart. Let's keep it apart. Then we will take additional fixed cost. Additional fixed cost would be 30,000. That is additional return, additional capital employed. Cost of capital or additional capital employed is 50 lakh into 2 lakh. 2 lakh is the additional capital which is reduced. So it will be 2 lakh into 15%, which will give 30,000 rupees plus contribution received from the discontinued product, which is 5 lakh 10,000. Therefore, the total amount will be 5 lakh. That is fixed cost plus cost of capital. Here we have the variable cost as 21. Additional fixed cost is 60,000. Then we have a capital requirement which is 30,000, that is 2 lakh into 50%. And then we have the contribution which is received from the discontinued for product is 5 lakh 10,000. When we add the entire sum, we will get an amount of 6 lakh, which is 5 lakh 10,000 plus 30,000 and 60,000. After that, we need to find how many units we can produce, or how many hours, how many units we can be produced from 60,000 hours. So per unit hour for manufacturing 1 unit of product C is 1.5 hours. Therefore 60,000 is the available hours. 60,000 divided by 1 hours, so we will get 4 lakh units, 40,000 units. So therefore the selling price will be the contribution of rupees 6 lakh divided by 40,000. will get the contribution per unit. That is 6 lakh divided by 40,000 is a unit. Therefore 6 lakh required contribution divided by total units manufactured of product C. That is 6 lakh divided by 40,000, which is 50. Add variable cost 21. We get the selling price as 36. So guys, thanks for watching this video. I hope you got clear and complete clarification regarding this illustration. If you find this video helpful, please subscribe.